We're going to be talking about the addition rule for disjoint events, and in fact, we're also going to be talking about non-disjoint events too. All right, so first things first, we want to just go over again what disjoint events mean. And then we're going to talk briefly about the meaning of the word or, because it has a slightly different meaning in statistics than in regular life. Then we're going to talk about how to calculate the probability of A or B. And that method is going to be called the addition rule. And we're going to talk about the addition rule when A and B are disjoint events, as well as when they're not disjoint events. Okay, so first let's talk about disjoint events. So remember, we said before, disjoint events are mutually exclusive events. They cannot both happen at the same time. So you cannot draw one card from a deck and have it be both a jack and an ace. It has to either be a jack or an ace, right? Like, you can't have it be both at the same time. Nor can you select a student at random from, let's say, in high school and get both a junior and a senior. They have to be just one or the other. However, you can select a card from a deck and have it be either a jack or a heart, right? So they're not mutually exclusive. They can both happen at the same time. They don't always have to, but they can, right? So if we wanted to draw this idea as a picture, we might show these two events. So this is the sample space of all the possible things in the world that could happen. Here's when A is true, so when your card is a jack, right? And here's when B is true, when your card is an ace, right? And notice that there is no overlap between those two things. There's no part of the space where both the jack part is true and the ace part is true, right? Whereas in this picture, we show non-disjoint events. And here we might have this as the space of all the events when jack is true. But here we have the space when the card is a heart, right? And here we have the space where it is both a jack and a heart, right? So here we see that it's possible for it to be both a jack and a heart. Here you might have jacks that are not hearts, like jacks of clubs or jacks of spades. Here we have hearts that are not jacks, like the king of hearts or the ace of hearts, right? All right, so now let's talk about the meaning of or. In regular life, we usually use the word or like this. Would you like soup or salad? Would you like it to be red or blue, right? And typically we mean, would you like one of these things or the other one? And you can't have both at the same time. You can only choose one, right? If you said, oh, I would like both soup and salad, they might say, oh, you need to pay for the other one, right? However, in math, statistics, and computer science, we're not necessarily talking about choices. We're really talking about truth values. So really, A or B means that either A is true or B is true, or A or B are both true. A and B are both true, right? And somehow, basically, so this big idea of this is that at least one of these is true, right? It doesn't. If both are true, you fit the rule. At least one of them is true, right? And so in that way, or means something slightly different in statistics lingo. So now we could talk about how to calculate the probability of A or B, and that's called the addition rule. And so first, let's talk about the addition rule for disjoint events. The way you could think about this is, what is the probability that you will land in this space or this space, right? Out of the entire space, right? So notice it's asking you, what's the probability that you'll land in one of these shaded areas out of all the other possibilities? So in that way, you could see why we might add together these two probabilities, right? Now, if A and B are disjoint, we need to first talk about what is the probability of A and B, that A is true and B is true, right? That both are true. Well, you could see that there's no place here. There's no space where both A and B are colored in, right? So that overlapping space between A and B. And so because of that, we would say 0. There's 0 part of the space where both A is true and B is true. We only have A being true or B being true, but not both, right? So here, now we want to calculate what is the probability of A or B. So you could easily see, well, we might want to just add together the probability of A and the probability of B. Right? So if this is 25% and this is 25%, maybe we have 50% likelihood of getting A or B. But that only works for disjoint events, right? So if we have disjoint events, the world is simple. But what about when we have non-disjoint events? So let's apply that same logic. Remember, when we talked about disjoint events, we were asking, what is the probability that you'll land in one of these shaded in spaces? So P of A or B means what's the probability you'll land in one of these shaded spaces? That is actually the same idea in non-disjoint spaces. But I want you to watch carefully. It's what's the probability of landing in A or the probability of landing in B. Notice that this space gets counted twice, right? So when you say P of A or B, what we really want to know is this sort of 8-shaped area, right? Sort of like, it looks sort of like that, right? And we don't want to count that part twice, right? So how can we come up with a general addition rule that will work even for non-disjoint events? Well, you might want to start off thinking about this in the same way we did before. Well, first, it might be helpful to add together the probability of A and the probability of B. But we've counted this part twice, so it'd be helpful to take one of those out, right? So we might subtract the probability of A and B, right? And so that way we lift one of these out, and we get just this area. All right. Now, the reason why this is called the general addition rule is because it actually works for disjoint events as well, right? So let's try for disjoint events. So we have probability of A or B, right? So like that. And here we have the probability of A plus the probability of B. And now let's subtract out the probability of A and B, right? So here, what is the probability of A and B? Well, that's 0 here. There's no place where it overlaps. So really what we're doing is adding these probabilities, adding these individual probabilities, and then subtracting 0, right? And that leaves us with the addition rule for disjoint events. So really, this rule, the general addition rule, actually works for all events, both disjoint and non-disjoint. Okay, so the generalized addition rule is quite important and really useful in lots of contexts. But there's actually a different way you could write it. And I just want to briefly show that to you here. What I'm just writing down is just the generalized addition rule. And now I'm going to rewrite this using slightly different notation. One of the frequent notations you might see is the use of union and intersection. And basically, union, this maps on quite closely to or. When you see union, think about or. And think about it like this, you know, when two like countries or lands like unite, right? You're thinking about two pieces sort of coming together, right? And now both pieces count, right? And that's the picture that you should think about or, right? When Alaska was united to the rest of the United States, it's like this big landmass and this big landmass, they're now like together, right? They're now counted as the same country, right? So it's really a or. Whether you're here or here, you're still in the United States, right? The other piece of notation you need to know is the intersection notation. Intersection. And this maps on perfectly to and. And so the idea is, where do they intersect? Where does A intersect with B? So we could just rewrite this using this notation. This is often used for sets, and so you could just use this notation. So instead of or, we would use union, A union B. And that would mean the probability of A plus the probability of B, we don't have to change anything there, minus the probability of A intersection B, right? So this is just saying this whole area shaded in, right, equals the probability of A plus the probability of B, but then take out this little section, okay?